Sir, we are in live, sir.
Okay, yeah, thank you. Hi everyone. Good evening. Thank you for joining this session. Let's start with the quick introduction here. So myself, Asma Zabin Qureshi, I'm having more than 6 years of experience, and I'm working as a technical lead with Encora. And yeah, okay, so today we are going to talk about the MongoDB aggregation. So I'll try to cover from basic to advanced level. And yeah, let me share my screen.
Oh, ma'am, you are in mute, ma'am.
Asma, you're muted.
Sir, ma'am is lifted from meeting, I think.
I'm back. Can I share screen? Sorry.
Ma'am, you can mute your YouTube audio, ma'am. That's why you get a feedback from that.
Am I audible now properly?
Yeah, ma'am, you are audible.
Okay. So we are going to talk about in the today's session will be the aggregation framework. After that we are going to discuss about the The next, the aggregation syntax. The aggregation pipeline stage limits, the best practices for using the aggregation framework. After that, we are going to talk about the different stages of aggregation pipeline, then the pipeline operators as well. So the pipeline operators and the pipeline stages, both are the different things. Sometimes people get confused between these two. After this, we are also going to talk about the what are the equivalent SQL functions with the MongoDB operators. And then lastly, we are going to do some hands-on exercise with the aggregation pipeline, its process, and how we can use that stage and the operators. Okay. Now let's talk about like what is the aggregation framework exactly. Okay. So now the simple query set in a MongoDB allows you to retrieve full or the parts of an individual documents. So what this mean by a simple query? So this simple query means like the usual queries which we use, like find document or the fetch documents, find and update. So those are the basic queries. It only allow us to retrieve a complete document, or if we want to fetch the part of the individual documents. They don't really allow you to manipulate the document on a server and then return them to your application. So let's say any kind of a manipulation we want. Let's say I'm having a 10 fields in my document and I want to retrieve only 2 fields, or I want to do some manipulation on those fields internally, so that I can do once my response is coming back to the server, coming back to my application, not on server, right? So this is where the aggregation framework from Mongo comes in. It's nothing external. It's not something kind of a plugin or any kind of external library. It is coming baked into the MongoDB only. So the aggregation framework is a way to query a document in a collection in MongoDB. So this framework exists because when you start working with manipulating data, you often need to crunch collections together. We want to fetch a data from multiple collections, we can say. We want to modify, also we want to modify them. In terms of modification, you can do anything, like you want to pluck out that fields, you want to rename that fields, or you want to concate them together. Documents by field, explode array of fields in a different documents, and so on. So there are the various kinds of a facilitate we are getting with the using of the aggregation framework. So this cannot be done by the traditional query system, which MongoDB comes with. So that is the which we are saying the traditional query is the same like the find or the update query that we cannot do, because if we are working with a large number of a data set, or the our document size is a much more, like we are having a 50 to 60 fields in a single document. Our schema is like that. So when we are working with that, it might be possible sometimes we don't want to fetch all of that 60 fields. I just want to fetch my category or my the product name or something. But in that sense, if I'm using a traditional query, it will give me the whole data in the response, which I'm not supposed to do, right? So in this situation, like the aggregation framework is works. Now we will going to see its use case. So using the crude find operation while fetching data in a MongoDB may sometimes become a tedious. For instance, you may want to fetch some embedded documents in a given field, but the find operation will fetch the main document, and then it will be upon you to filter this data and select a field with all embedded documents, scan through it to get ones that match your criteria. So here, what I mean by the embedded document is the similar like the nested document. I can also show you an example for the nested document. See, I'm having one record, I can say one document here. So here I can see this is what embedded document. The data fields inside the fields. So here I'm having a relationships. It is a type of an array and it's array of an object. Also inside this object, I'm having one more object, which is a person, and it is also having some data. So this is something kind of embedded document we can say. So let's say I'm having this fetch, if I'm having this record and I'm doing a fetch query, but now I want to just fetch a data which is just let's say I want to fetch only the relationships of the person Dave, right? Now, if I will do the find query, it will give me all of the data unnecessary, which I'm not requiring. I'm completely going to ignore this. So this is something we can do with the aggregation framework. We will check this, how we can do in the hands-on exercise. Okay. Now, another thing is like, there is no simple way to do this. Like you will be forced to use something like a loop. So the same thing, like I'm having a relationship of field, which is having array of an object. If I want to find like the name is Dave, I need to loop. First, I will fetch that document on my application. I will trace to that field and then I will run a loop like to check like, okay, this relationship is matching with the Dave name or not. So that is kind of a looping. We need to go through all these sub documents until you get the matching results. Now, if we are stick to this method, like what if we have a millions of embedded documents? You will unfortunately like get frustrated with how long it will take. So beside the process will take a lot of your server's random memory and maybe terminate the process before you get all the documents you wanted, as this document size may be suppressed. So this is also another challenge. Like you are having a lot of fields in your single document, and now you are having a document in the number of lakhs, not in, even in the thousand. I'm having a records in my collection, which is a more than a 1 lakh, and each document is having a length of like 50 to 60 fields, and it's also an embedded. And I'm doing some this traditional looping thing, then it will not the proper way to do that. So regarding the limitations associated, especially with a large number of documents, there is a need to group them to enhance the scanning process. And the aggregation framework is therefore an operation process which manipulates documents in different stages, process them in accordance with the provided criteria, and then return the computed result. So that is what we can see in the pipeline stage. Like this is what I mentioned, like we will manipulate in different stages, then we can do a processing, and then we will return the computed result. Now, the aggregation framework provides a rich set of aggregation operator expression for analyzing and manipulating arrays. When optimizing for performance, these array expressions are critical to avoid unwinding and regrouping documents, where you only need to process each document's array in isolation. So for most situations, when you need to manipulate an array, there is usually a single array operator expression that you can turn to solve your requirement. So we are having a lots of different array operators also available in the pipeline, which do the unwind or winding of the array. We can also replace its roots of an array. We can push any new fields. That is what we are going to discuss later in this webinar. The next section which we can go through is the aggregation pipeline. So typical pipeline structure, if we can, can be visualized, it's something like this. So we can start with the pipeline only with the one collection. We cannot ever run a aggregator query for two source collection. Initially, we need to target one collection, and later them in the stages we can also fetch a data from another collection, which is the use of the lookup stage. So initially we can only target the one collection. The multiple stages we can add, and at the end we will get the output whatever the retrieval or the manipulation process we have done here. So to scan the documents one by one, in order to apply some operations to them, will obviously outdo the purpose of the aggregation framework, because it will consequently take much time to do this. Therefore, the data processing is done at the same time from a different stages using the Unix pipeline technique. So documents from a collections are channeled into the multi-stage pipeline, from which they are converted into aggregate data. So this pipeline consists of certain stages where certain operators modify the data, the documents in collection using a various techniques. So finally, the output is returned to the application calling the query, and compare it with a simple query like a find. Sure, the find query will work in a most of the ways, but it is not really very useful when you want to modify the data and as well as you want to retrieve the data at the same time. Because let's say if you want to retrieve and modify it, you need to use more than a one query. But the aggregation will help here. It will do all of the things in the single query, and it will return you the data, whatever you required. Either you will need to fetch the documents and modify them accordingly in the application on the server, or worse, you'll send them back to client and let the front-end code modify it for you. In both the cases, you are wasting the resources and the bandwidth. So here we can say that this is to address this problem, we can take a help from the aggregation framework to replace those traditional queries. An aggregation pipeline also consists of one or more stages that process the documents. Each stage performs an operation on the input element into the input documents. Like for example, one stage can filter the documents, another is doing the grouping the documents, and third one is doing the calculation of the values. So the documents that are output from a stage are passed to the next stage. So one stage output will be the another stage's input. It will treat like that. The input of the pipeline can be a single collection, what I just addressed in the initial topic start, where others can merge later down in the pipeline. Also, the pipeline then perform the successive transformation on the data until our goal is achieved. And also, this way we can break down a complex query into the easier stages. And in each of which we complete a different operation on the data. So by the end of the query pipeline, we will have whatever we will achieve like whatever we wanted, and we can add a multiple stages in between if we want to filter out the more data. Okay, so the another one will be the aggregation syntax. We can quickly take a look at that as well. So the typical aggregation syntax, I can say here we can having a database object. Then we can put a collection name on which collection we want to do the aggregation. Then aggregate keyword, the function. Here we can pass our pipeline. So this pipeline will be the list of stages we want to pass on. And these are the option. So this is completely a optional parameter. Whatever the option, if we want to pass, we can. Otherwise, we can completely ignore this and we can continue with this pipeline. Here also, I have put one of the example like this kind of a stage we can use, like the match, group, or the sorting. Each stage should start with the $sign only, and this will pass as an object of the pipeline array. Now, there is a pipeline stage limits, like how much and what kind of a pipeline stages we can include. So number of stages, like no limit, but as the aggregation work in the memory, each stage can use up to 100 MB of RAM. So number of stages, it doesn't matter, but how much data, how much data it is playing around and how much memory it is occupying, that is having a limit. Like each stage can use up to 100 MB of RAM. And if you will exceed this limit, you will get an error from the database. So if it becomes an unavoidable problem, you can opt to page to disk. So there is one solution, like if it becomes unavoidable problem, you can opt to page to disk, with the only disadvantage that you will wait a little longer because it is slower to work on the disk rather than in the memory. So to choose the page to disk method, you just need to set the option allow disk use to true, like this. Like I mentioned in that syntax part, like we can pass the options. So in that option, we can use this allow disk true, and it will set for that memory, not instead of the memory, but on your disk. So the return documents, the documents returned by the aggregation query, either as a cursor or stored via out in another collection. There is also a limit of 16 MB. That is also a limited to 16 MB only. And they can't be bigger than the maximum size of a MongoDB document. So now, if you are likely to exceed this limit, then you should specify that the output of the aggregation query will be as a cursor and not as a document. Also, there are various clusters in the Mongo, which is having a different categories, and it is allowing you to avoid this kind of a limitation, or with the increased limit of the documents or the memory. So that is this is something basic we are talking about. But if you as we just increase with the clusters on the Mongo Atlas, it is having a various way to handle this situation. So this is not something kind of not unavoidable or something, but it depends on the what kind of a cursor. These are just defaults one we are going through. Okay, now there are some best practices also while we are using the aggregation framework. So that will helpful for us to give a much better and a faster performance for your APIs. So as we say, like with the great power comes with the great responsibility. So you can easily exploit the aggregation framework for doing a simple queries too. If you are not if you are not having a that much deeper knowledge, and if you are trying that aggregation query, and you will find that no, this is not something giving me a quick response and not helpful, so that might be a reason you are not using it properly. So before using that, there are the certain things which if we will keep in mind, we can improve and get a best of that query. So that is something like MongoDB will reject any operator that takes more than 100 MB of the RAM, and that will throw an error. So when we are writing a query, we need to keep in this mind of these things as well. Like if it is giving an error, this might be something of the data which we are having, it's not the proper one. Or we need to take a look at that our data, what we are performing the aggregator query. Another thing is order matters. So let's say we are having a different kind of a stages in the MongoDB. Now, if you are not putting match first, then it will not give you a proper, as I mentioned that one stage is output is the input of the another stage, right? So if you want to do some filter out, then you should use the match operator first will reduce the number of document passed to the next pipeline. And putting the project next will then further reduce the size of an individual document by getting rid of the fields. So whatever the stages we are using in our aggregator framework, it completely matters like what are the things we are passing and what are the stages in which order we are passing our stages. That is also a matters. Finally, make sure like you do all the work which requires the use of the indexing fields before you use operators like project or unwind, because these operators create a new documents that do not have the index from the original document. So indexing is also a better option to work with the aggregation framework. Okay, so next we are having the different stages of aggregation pipeline. So these are the few I have mentioned over here just to get an idea. There are many other apart from this. It's not limited to only this which you are able to see. These are just a few of them. So the most popular I try to just cover like the match to filter out the data. So we can use the match. Let's say we want to find a document with the name, like just search movies with the name. And so this is simple query we can use with the match stage in the aggregation pipeline. Another is the project one. So the project one is also a most popular and most used stage to display the fields. So let's say you are having 10 or 50 fields in your single document, but in response you don't want to pass that 100 fields, you just want to pass only 2 fields in response. So that is also we can achieve with the use of the project documents. Another is the grouping, then the out. Unwind is used for the arrays. The sort stage is used to do any kind of a sorting in the documents fetching. Then the limit we have for the pagination purpose, we can use the limit and the skip stage. Another, we have the count documents to count the documents, whatever we are passing in the pipelines. Another, we have the lookup. Lookup is the most important when we are fetching, we want to fetch a data from a multiple collection. So lookup will help us here to fetch documents from more than one collection. Another is the add field. Let's say if we want to add one new field, either at the 0 level or the first level, we can use this stage. The facets search is also very helpful. Then the unset, to just unset the values, or we want to remove the fields. The merge, fill, and the set. These are the some of the stages I try to put on here. Others you can also check out. I will try to cover few of them in our hands-on exercise. All we can't cover, I think. Okay. Now the next is the aggregation pipeline operators. So these are the pipeline operators. This is we cannot consider as a stage. This is the operator which we can use in the pipeline stages. So let's say we want to do the sum of some fields, like we are having a student collection. We want to summarize its each individual student's mark we want to sum, or any of the sum we can use the sum. There is a main max. This LT is less than, LTE means less than or equal to. This GT is the greater than, greater than or equal to. This is an equal operator. Also, this is in, if you want to just search from your array, you can use this operator in. Then the reduce, the map reduce, what we used to do. This is something exactly the similar one. Also, we want to have the replace one, or the replace all, not equal to, not. So these are the all as well, the only the few of them I just listed down here. There are many others operator which helpful, very helpful to achieve our goal if you want to manipulate a large set of a data, or we are manipulating or the playing around with the lots of fields in our document. So this is what we get facilitate with the different stage and operators, and it is get our job very, very, very easy to play around with the documents. Instead of fetching a whole document and do the manipulation on your code side, whether it is a front end or a back end, the aggregation will allow us to do all kind of things on a server level itself on the database side, and it will give a proper result. So this is something we can say a very much easier task for us to do this. Okay, now the another thing is there are some debate happen sometimes, like with the non-relational and the relational database. Some person which is new to Mongo is having the conception, okay, this kind of a functionality we don't have in the MongoDB, but the SQL is having this, but this is not true at 100%. So in a relational database, like you store each individual entity in its own table and link them together through the foreign keys. But while MongoDB certainly supports the references from one document to another and even multi-document joins, so it's a mistake to use the document database the same way you want to use the relation one. So the way of you are using your database with the relational database and the non-relational is completely a different mindset. You cannot something say, okay, let me just sync together with some keys or some common fields. No, you can do something like the nested. You can take a help of this embedded document or nested things, and that will solve your problem completely. And also there is a one limitation with the embedded documents, like you can nest documents up to 100 levels only, and the overall document size must not be exceed with the 16 MB. So this is something is with the relational and non-relational here. And also we can see some of the most of the function we have the equivalents in the SQL function and in the MongoDB. So in SQL functions, if we are having a select query, like to select the fields, so the same way we are having in MongoDB the project stage. If with the help of project, we can retrieve only the fields which we want. Then in SQL, if we are having a where or having clause, so we are having a match stage, which will do the exact same thing what in MySQL where or having is doing. Now a lot of people is having a misconception, or having such mindset like, okay, SQL is supporting a joins, but MongoDB is not providing that. But it's completely false. We have the join, we can fetch the documents even one or two collections with the help of aggregator query and using this lookup stage. So lookup stage will do the same thing what the join will do in the SQL function. So there is no kind of a limitation we can say here while fetching a data, like, okay, SQL is giving more functionality or the feature and Mongo is not giving. It's just the way if you will explore that, you will get a better and better in this Mongo operations. So the SQL is having a limit, same way the MongoDB is also having a limit stage. Here we can do the group by. Those are the same way we have the another stage of the aggregation, which is a group. Order by, we have the, instead of the order by keyword, we have the sort thing, which is doing the exact same manipulation. Here we have the count. Also we can do this by both of the stage, the sum or the sort by count. Sum is also having the same with the same keyword, and the average. So this is completely almost the same. It's just the syntax is different, and the stages or the way of we are using is different, but it's not something we cannot achieve with the Mongo while we are using this and SQL, because yes, but agree on that, like with our traditional MongoDB query, like only the find or the update, we cannot explore that much. But if we are replacing those traditional queries with the our aggregator queries, that will definitely a game changer thing. Okay, let's move to the some hands-on exercise here. So let me share my screen. Okay, simply we will start with the match only. Let's start with the aggregator. Okay. This is where we can pass. This is the array. Here we have the different stages we will put. First, we will try with the simple match operator. Now, this is a company's collection. I'm having only here 11 documents. I'm not over right now having a large data set. I'm just having 11 documents here. And I will fetch my company data simple with the, let's say for the name. So here I will pass, okay. My company name will be Cisco. Okay. Now I'm getting this one single document, but let's say I'm having a requirement of that, like I don't want a complete object. I just want it. See, this is something which we are overloading a server. If my single document is having this much of a lot of data, and I'm just having a requirement of just to fetch my any of the one field, let's say a founded year. I just want a founded year here. So what I will do here, I will add one more pipeline stage, which is a project. I will add founded year and I'll put 1. So 1 is something like I just want in response the founded year. Now it will return 2 fields only, the ID and the found year. Now I want to add one more thing here. If I will switch this 1 to 0, what it will do, it will exclude only founded year field and give me all of the other ones, the remaining one. See, this is again returning me the whole document, but you will see that the founded year will not be in the response. It just excluded. So if you want to exclude the fields from your response, you can use the 0. If you want to exclude 2 or 3 or them, you can put a 0, and rest of the things you will get in your response. But if you just want only specific fields, then you can use it with the help of only 1. Now, if I'm removing this match stage and I'm using only project, then what will happen for all of the 11 documents, it will return the name on the founded year. See, so each of this company is giving me a response with the founded year only. So this is something a match and project operator will work. Another thing which we can found here is we can also add some additional fields. So let's say match name I'm putting here is CBS. Now for this document, I want to add one field here. Okay, here these are the investments or the acquisitions. Okay, let's take an example. I want to add a field which is having IPO. Let's take an example of the IPO. I want to add more field like IPO, and here I will add like is active or something. I will add one field over here. So how we can do this? We can use this. We can do for all of the documents, or also we can do with the match document only. Like I want to add this field only for the CBS company, not for the all of the. If I will remove this match stage, it will add for all of the 11 documents. But I just want to add here only for this document. So this we will use add fields. There is an IPO dot is enable, and I'm making it as true. And I will run this. Now we will check. See, this is what the field is added only for this document. We can check another documents and it will not there. We can check another document and IPO. This is the IPO is null. So here it is not added. It is just, it is taking, it will filter out the data. Okay, it will fetch that whatever the company name is CBS, just take that. This output will pass into this stage as an input. It will check the field, check the stage name. Okay, this is the add field, and this is where I need to add my field. Let's say we want to add some field on a 0 level. What I mean by the 0 level is where my name is, and here I want to add is active. Let's say this company is active or not, that I want to add. First we will check, do we have such field or not? Is active. That is a no field, right? So I will do the ground level. I will add one more field. So here I can add is active, true, and it will add that field. We can check is active. See, with it true. So this is something, if we are doing the nested, we need to put a dot, 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 and then we can add that for the embedded documents. And for the ground level, we can do like this. One more important stage we can do, the join ones, the lookup which we are considering. Okay, now let's say I'm having one more collection, which is this collection is having all of the movies data, what it's generate the runtime and everything. This is also a very big document. See, it is having all of the information of the movie. Now I'm having one more collection, which is a comments. This comments is specific to any of the movies which is in my movie collection. So here what I will do, and here we have the movie ID, which is coupled from this collection. Now I would like to fetch a movie with all its comments. I don't want to do two kinds of a query. First I will do find queries getting all of these IDs of the movies, and I will run one more query for the comment collection, and I will fetch appropriate matching with the IDs. So this is something we can do with the aggregator query using the lookup stage. So let me open the another shell. Here we can see aggregate. what we can do here, the lookup is having three kind of things, like one we can see a from, like from which table you want this. Here, which table you want to do a kind of a join. So here initially we have the targeted table, the movies, and also we want to fetch the movies comment from its comment document. So we will put over here a comments. Then it will be having a local field. Local field, something, okay, local field. Another will be the foreign field. And last, what that joins data you want to call. So we can put this here as comments. Okay. Now the local field will be the ID, because my movie, this ID is attached to the comments collection of the movie ID. So the foreign field will be here is movie ID. Okay. Now, first we will see we do not have any kind of comment object here. I can show you comment. There is no such object, right? Now, as soon as I will run this query, it will give me all of the comments from the comment table with its comment object for each particular movies. And here let's do one more thing. Instead of checking in each and every, we will do a project. It will be easier for us to track like how much is retrieved. So here we can, I think, say a title we want to display, then comments, and yeah, that's it. ID will be fetched automatically. So okay, so this is what we can see, the title for all four fields. The two comments is corresponding to this movie. One single comment is for this, and this is what we can get in a single document. Here I can see my title and comments. So I can do this with the help of a lookup, by like fetching a data from a more than one collection. This is something same as a join we are doing in the MySQL thing. There are a lot of more, we can also add looping inside the pipeline stage. Also, we can change the nested document structures, manipulating the arrays and everything. There are a lot of stages and operator are there to facilitate and give you a more and more convenient to manipulate and fetch your data, or when you are driving or doing a manipulation. So there is a lot of thing which is doing a playground area, I can say, which is not covered in the small session, but yeah, that is definitely a good. One more thing, let's quickly talk about that operators, which these are the things which we have seen, that is completely a stage part. Now there is a one more section we have covered, which is the different kinds of operators. So let's say there is something more also. Let's say in my company's collection, I have one field is a founded year. Yeah, see, this is the founded year. Now, let's say I want to fetch the company data, which is founded year is either 2002 or more than 2002. I want to just fetch out those data only. So here we will try to do this. I think this is, we are not here getting the match one. Here we can directly do the project. Also, I want to fetch a name, so I'll be getting more idea like what are the company name, and okay, let's say not in the project, but I think whatever the founded is greater than match. Okay, the match and the founded year, I think. Founded year. Here we can use that operator greater than or equal to, we can see 2002. And here I want to just project. I don't want a complete thing. I just want the name of the company. Name of the company and founded year. Founded year. I can say. It's not. Okay, sorry. Here, this is not a string. This is. Okay, so here we have the list of the companies which is founded year is either 2002 or later 2002. So these are the data we are fetched. The total 8 companies is that. Now, I think we can also go for one more if-else example, which we can talk about. So also there are the, let me check this. Okay, so for the if-else example, I think we can go for the funding rounds. So here we are having a data like the how many funding rounds of the particular companies is having. So we will count in the aggregator query, we will count like how many do a number of rounds its particular company is having, right? So here I can see a lot of things. Okay, we will fetch the funding rounds data uh, in the new field. Like we will add one more field here. I can take 1 2 3 4 5. Okay, so this particular company is having a 5 funding round, so I will add one more field here, number of fundings at the name, and in that field we will calculate or do the count of this funding round and we will save that value. So let me try around on that. We will remove this match object, no need of it. I want to do this operation on every of the all 11 documents. So here I will put number of funding, and here I will take the condition, dollar condition. In condition we can put if the funding round of is an array. So here we can put if dollar is array. So if this funding rounds can put the funding rounds. Okay, so this is something like if this is an array, then the size of we need to what we need to do here. First we are checking, because when we are calculating a size we need to make sure that funding round should be the kind of a array, so then only we can do the counts here. Then dollar size, this is another operator of the stage. Size of which size we whose size we can put this funding rounds. We can put also the else condition. Else it will be null. So here I'm adding one new field, which is a number of funding in my. So this is something I'm not adding this field onto the database. This is I'm just creating a temporary field on my server, which I will get on the response, where the response will coming back onto the application. So this field we can see in our response, but when we will check on the database, it will not show this. For that, we need to use that add field stage of the pipeline. So let me just run this. So here we can see the all of the, okay, so the Facebook is having like the 11 number of funding rounds. These are the 6, 0, 7, and this. Now this, as I mentioned, this number of funding we cannot see in the database. This is just we created that field on our application requirement. Number of fields, you will not be able to see that. Number of funding rounds. So it's not there. It's for that we need to use the another stage. This is just a projection. So projection will use only for your response manipulation if you want to exclude or include some fields. So this is something what we can say most of the things we generally use in the MongoDB. This is very something less we can just go through, but there is a more there is a lot of more we can dig into as per what the application is required and we can do. So I think I'm good on my end now on the exercise side. If anyone is having the question, answer, any doubts, so we can go on that side.
Asma, there are no questions.
Okay, David. Thank you.
Okay, thank you for the session, Asma.
Thank you. Yeah.
Thanks for the webinar.